All right, so radical functions, 10.3, graphing cubic functions. F of x equals the cube root of x is the parent function. The domain is all reals, range is all reals, and this is true for all of the cubic functions, or cube root functions. So this is what we look like. This is a little table of values I use to graph it. We have our translations here. G of x equals a cube root of x minus h plus k. A still stretches the graph vertically, h translates the graph horizontally, and k translates the graph vertically. We also have our other one where it's 1 over b, where b is the stretch of the graph horizontally. The values are staying the same. A, b, h, and k will do the same thing to all of our graphs throughout this entire year. And we will look at those translations and how they are. The graphs themselves will look different. The reference points will be different, but how we use A, B, and H, and K is going to remain the same. So the reference points we're going to use for our cubic functions are -1, -1, 0, 0, 1, 1. If you like, you could use -8, -2, and 8, 2. It's just that they're very big numbers, and sometimes they'll get really hard to kind of graph. So I want to look at graphing some of the cube root functions. And we have, our first one is g of x equals 2 times the cube root of x minus 3 plus 5. And if we look at this and identify a is 2, h is 3, and k is 5, remember, a changes the y value. So we're going to multiply the y value by 2 in each case. You can write it on each one or just at the top. And after we do that, the h value changes the x, so we're going to add the 3 to the x. And then after we multiply by 2 on the y, we're going to add 5. And we're going to get some new points. So -1 plus 3 is 2. -1 times 2 is -2. -2 plus 5 is 3. So 0 plus 3 is 3. 0 times 2 is 0. Plus 5 is 5. 1 plus 3 is 4. 1 times 2 is 2. Plus 5 is 7. And we're going to graph these new values. So we have 2, 3, which is here. We have 3, 5, which is here. And then we have, 4, 7, which is here. Now remember, these are going left to right. So sometimes they're a little challenging to draw, and I get that. And connect the dots. Do the best that you can to make it look left to right in kind of a zigzag. And there we have our graph of our cube root. The domain and the range are still all reals, so we don't need to necessarily rewrite them every time for these. Looking at our next function, number 2, we have a b value. And the b value, remember, is getting multiplied to your x's. So let's look at our reference points here. Let's get them written down. We have -1, -1, 0, 0, and a 1, 1. Now, when we start looking at this and looking at what's happening, the b value is 2, the h value is 10, and k is 4. So that means we're going to multiply x by 2 and then add 10, and then add 4 to the y value, because looking at our shifts and our translations. Here we go. -1 times 2 is -2, plus 10 gives us 8. -1 plus 4 is 3. 0 times 2 is 0, plus 10 is 10. And 0 plus 4 is 4. And then here, 1 times 2 is 2, plus 10 is 12. 1 plus 4 is 5. And we're going to graph our values. So 8 is up at 3. 10 is up at 4, and 12 is up at 5. And remember, these go left to right when we make our little snake. And there you go. Do the best that you can to make that little zigzag snake. Making it make that kind of loop and that change in the middle. Now, that leads us into being able to write the cubic function in the given form. We practiced this with the quadratics, and we've practiced it with other ones as well, and so it's kind of very much the same type of idea. And so we're going to write the cubic function in the given form. The first one we're going to be looking for an a value, and then the second one we'll be looking for a b value. So it's important to note that middle point, that change, that interval change, is what our h and k are going to be. So for this equation here, we have g of x. This is our h, this is our k. So we're going to have a cubed root of x. H is 1, so minus 1, and the k value is a 7, so plus 7. Now, to be able to find the a value, we're going to use our other point, that 2, 9 that they gave us, and plug it in and find the a value using that. So 9 equals a cubed root. A is not cubed, it is the cubed root. Let me move that over. 2 minus 1 plus the 7. So I'm going to move the 7 to the other side. I'm also going to simplify in there. So we get 2 equals a times the cubed root of 1. Cubed root of 1 is just simply 1. So I have 2 equals a times 1. The a times 1 is just a. So a in this case is 2. So we go back and we rewrite our equation. G of x equals 2 cubed root x minus 1 plus 7. And there we have our equation from our graph. Now, for number 4, I'm going to move this little graph right here and create a little bit more space for myself. I'm looking for a b value. But again, I want to use that middle turning point. That's my h and my k. So right here, h, k. This is my other point that I'm going to use. So we're going to start. G of x equals the cubed root 1 over b, x minus, now look at my h, it's a negative, so it's a minus a negative 3, and then it's a plus 2. So g of x equals the cubed root 1 over b, x plus 3 plus 2. And I just like to go back in and clean that up. Now we're going to plug in that other point for x and then g of x. So we get 3 equals the cubed root of 1 over b, and this is negative 1 plus 3 plus 2. I am going to clean up the negative 1 plus 3 and that plus 2. I'm going to move my equation up here so it's kind of got some space so you guys can all see it. So we're going to subtract the 2 both sides. That gives me 1 equals the cubed root 1 over b, and I'm going to take care of this negative 1 plus 3 to make that a 2. This right here, that's just the tab. Now, to get rid of that cube, because we can't take b out until we get rid of the cube, means I need to actually cube both sides. So 1 equals 1 over b times 2. We don't cube the 2 because it's inside the cube root. I am going to multiply both sides by b. So I get b equals 1 times 2. So b is actually 2. And now I can go back and write my equation. So g of x equals the cubed root 1 over 2 x plus 3 plus the 2. And there's the equation to that graph. So take some good notes. Make sure you have everything ready for tomorrow.